Cool. Hi, everyone. Thank you. How's everyone doing on the Thursday? Who's catching a plane later? All right, who's catching a plane tomorrow? Cool, OK. So are you going to go party the last evening? OK, good. Welcome to my session. So I just finished my slides. Let's see. Next. Oh, cool. So I'm Robert. I work for ITQ. We're a consultancy in the Benelux, well, actually in EMEA. And we do a lot of across-the-board VMware stuff, infrastructure, but increasingly cloud-native. We have about 22 cloud-native people, and I'm one of the practice leads for that group. So I work with a lot of customers, doing a lot of Tanzu-ish stuff, a lot of TKG. I'm also part of the Vanguards. Yeah. OK. Which is kind of like a focus group of customers and partners for VMware. If you're doing anything with Tanzu, have a look at the Vanguards. It's really cool. You'll get a lot out of it. A lot of like behind-the-scenes stuff as well, and roadmap stuff. You have to sign a bunch of NDAs, but you know. OK, so yeah, I don't really have slides. I'm just going to show you the template I was given. No, actually, I do have some slides. Apparently, Hock said AI is easy peasy. But don't worry, I'm not going to do a talk about AI, because that's been done to death this week. But I did use AI because I needed some slides. So I asked it to create my slides. It's OK, I guess, kind of. You can do graphics. And you had to import the code before. Now it can just generate the image, because it's multimodal, you know. Anyway, so I made a nicer one. This session is about Kubernetes resiliency, but there's too much to cover in 20 minutes, 18 minutes. It's a huge, huge topic. There's so many aspects to this. I'm just going to cover like some real basic stuff, but it's this most important stuff. So in the infra world, we're kind of used to these two, right? We'll have. Sometimes we won't have any resiliency or high availability at all. It'll just be one thing, in a VM, and then we trust vSphere HA, which is probably good enough, right? But sometimes, you have Postgres or Microsoft SQL. We've had Windows clustering for way longer than vSphere even, right? But it'd usually be something like this: active-passive replication, and then if you get into the realm of things like stretched cluster with vSAN, that's actually an active-active system. You can read and write on both sides. That's really cool, really handy, super resilient. But then it gets a bit more complicated, because what if this thing breaks? All right, the link between the two sides. So now we need a witness to be a tie break in case this breaks, right? So this is the resiliency models we're used to in the infrastructure kind of on-prem enterprise world. But when you talk about cloud native, you're talking about microservices architectures, and you're talking about distributed systems. And distributed systems work kind of like this, as in multi-nodal, n+1, stretch horizontally, and everything replicates to everything else all the time. And it's also active, 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 active. And you trust these systems to deal with state in their own way, in a consistent way, so that you don't need to worry about it. So the new generation of database models are all like this. And Kubernetes itself uses something like this. It uses etcd, which is a distributed database model that works like this. But notice how I've drawn 3 boxes. Because remember, for active-active, we needed a witness. Well, if I can also just replicate the data across 3 nodes, and then I have quorum as well. So if there's a split anywhere, like here, this will solve that as well, because basically each of the nodes acts as a replica in these kind of systems as well, right? So this is a really cool way. I can write and read and write everywhere. The data's available everywhere. It's being replicated everywhere. It's available everywhere. And it's resilient against interlink failures between the components. Yeah? This is a very cloud-native way of doing state and doing data. So in the cloud-native world, this is what everyone is used to doing. If you've built a cloud-native application architecture in public cloud, you have AWS, Azure, whatever, gives you availability zones to use. And you say, OK, I'm going to put part of my app in this one, and this one, and this one. And the application, or the data service backing the application, should look like this. So you get that. Right? And the application is responsible for dealing with its data concerns. In the enterprise, however, this is our reality, right? 2 data centers, and data concerns are not left to the app. They're left to infra to solve, using metro cluster, stretched cluster. If it's a database team, we rely on them to do replicated Postgres, replicated Microsoft SQL or MySQL, clustered. I say replicating. I'll usually talk about the cloud native when I say replication, right? But it's all the same thing. This is like fitting a square peg in a round hole, or the other way around. These models are not compatible with each other, actually. Because if I have a 3-way thing, how do I put 3-way into 2-way? Do I put these 2 in there? Or do I put that one in there? OK, I guess that would work, but what if this fails? If there's one over here and this fails, then this dies because it has no quorum, and this one will survive. But then I'm like, OK, so I always kind of know which sites will survive, so I always have a leading site. But we know this. We know this from vSAN as well. We know that from stretched cluster. There's always a site that wins. If all things being equal, there's a site that wins. Same here. But what if this site, if I have 2 of these sitting here, what if this site dies? I lose the service here because the site died, but I lose this one as well because whatever's left here doesn't have quorum. It dies as well. So this is a problem, right? This is why you can't stretch Kubernetes across this. The moment you try this, you create an unstable situation. And that's the reason vSphere with Tanzu does not support being deployed on a stretch. They won't support it, and this is the reason why, right? So there's a problem. How do we deal with this? Because if the enterprise comes to us, the business comes to us as infra people and says, we're used to you taking care of availability concerns. Solve this for us. How are we going to solve this? Now, the answer right today is kind of simple. Oh, by the way, yeah, more AI fun. That's what it came up with. It's pretty cool. I don't really know what's going on, but it's kind of epic. So right now, the validated design, the design you go for is basically this. I do a K8s cluster on one side. I do a whole nother K8s cluster on the other side, right? And I don't stretch. I don't do data center stretching. I don't do vSphere stretch. These are 2 separate clusters, right? By the way, if I didn't have time to put the graphic in there, but if you go to the vSphere 8, vSphere with Tanzu documentation, there's now 2 deployment models, right? One is single cluster, single site, single availability zone, in other words. And the other one is basically this, right? 1, 2, 3. They do a 3-zone architecture. Now, the funny thing is, if you read through those docs, you're basically like, does this mean I need 3 data centers? Yeah, kind of. Like public cloud. Who has the money to do this? Who's going to buy a 3rd data center? Right? Not many of us. But it's a conversation I'm having with some customers. They say, if you want to do this properly, you actually need 3 data centers now. And they call me crazy, and I don't blame them. OK, so this is the way we go for now. Cluster on the left, cluster on the right. But that doesn't actually solve our problems, because we can now run stuff inside the cluster, but you have all these different kinds of data types. And guess what? We're back to the same problem again. Because, if I have a Postgres database, I can have a passive replica on the other side. Which site lives and which site dies? What happens when the inter-site link goes down? What happens when that site fails? Does that fail over to the other side? No, because we're not stretching, so we don't have vMotion. So how do I get Postgres to automatically come up here? right? Now, Minio is slightly more cloud native, so you can do some more interesting things with that. But remember, I still have to divide things over 2 sites. The model doesn't fit, in other words. How do we do these things? So, I don't have an answer for you. Presentation over, right? I actually don't, because the industry doesn't. Everyone's struggling with this right now. As more workloads, cloud-native workloads start to be developed inside enterprises, and the enterprise topology is 2 data centers, no one knows how to solve this. Everyone in the cloud-native community are like, well, do it in public cloud. 3 zones, what's the problem? The problem is this. We're going to have to deal with this somehow. We'll do questions after. There's another part of this puzzle that we're going to have to deal with. Because if it's the workload, if it's the app, especially if it's cloud native, I can leave app and state and data concerns probably maybe to the application team, to the application owner, to the developer, whoever came with the application, right? But many of these workloads, they simply assume they exist inside one Kubernetes cluster. And they say, look, we need data. We're going to make some volumes, persistent volumes, right? Kubernetes. So you get persistent volumes. How am I going to get the data over there? Now, I'll tell you, public cloud doesn't do this for you, right? I mean, there are some extra services probably in Amazon, I haven't looked recently, that allow you to do data replication. There's nothing in the vSphere portfolio, the VMware portfolio right now, that can do this if there's not a stretch already underneath. And remember, stretch is not supported. How do we solve this? We can't. There's no answer. Right? Now, there are third-party solutions that might be able to help. I might not want to mention them here. But this is a real problem we have to solve. If an application owner says, we're going to build me a cluster, produce me a cluster, and I'm going to put a workload in there, you have to ask them this very simple question. Are you going to back up your own data? Are you responsible for backing up the persistent volume objects inside the cluster? And if they say, no, infra takes care of that stuff, right? That's a conversation you need to have with your application owner, with the vendor, with the developer, whoever's coming to you and saying, we need Kubernetes, we need TKGS clusters. Now, if you're lucky, you can keep the data outside the cluster, right? If you have an established DBA team or whatever it is, you can outsource it to them. And then some of that problem goes away. But most Kubernetes applications, it's hard to pull out the database. Sometimes you can't do it architecturally. Sometimes the Helm chart gives you an option, right? But what if the only one they support is, I don't know, MongoDB, and your DBAs only do Postgres or Microsoft, right? So what are you going to do then? Right, just stick it in there, but then how do you get it there? So part of the solution might just be to redeploy stuff, but then, and then restore from backup. But then how do you get the backup over there? Do you guys know how to do backups in Kubernetes? Right, Valero? So the nicest thing about TMC is it gives me a nice UI front end for Valero. That's my main use case for TMC. If you can run TMC. But in other words, you're going to probably have to do that backup for them. And if something goes down, you're going to have to import it, restore it here. You probably want to script that, right? Because you're going to have hundreds of these, and you're going to have terabytes of data in these. But the point is, you might have to deal with it. Actually, I'm going to guarantee you're going to have to deal with it, because not all apps are going to take care of it for you. Is there some water somewhere? I forgot to bring some water. I'm like, ah. These are important too. None of this works in isolation. We all have dependencies. Now, you know the usual dependencies, right? DNS, Active Directory, NTP, stuff like that. But the way most advanced users will... Oh, thank you so much, sir. The way most mature application teams will put stuff into Kubernetes is usually in a GitOps kind of way, using Argo CD or using the stuff Tekton built into TMC to do GitOps. the registry, right? Harbor. You're going to run Harbor inside. Harbor has a PV. You need to back that up. Harbor doesn't do it for you. It's probably the first thing you're going to have to back up is the Harbor image registry persistent volume, right? Or you have to replicate it, but you know, the failover is not automatic. Oh, another one. Great. Thanks. Awesome. I can choose. This one's better. You could run these outside of Kubernetes. It might be a good idea in some of these cases. There's a bit of a chicken-egg problem going on here, right? Because some of these dependencies sometimes run inside the cluster itself, or a separate cluster, but it's, you know, you can't stretch any of them. So remember that when we're used to thinking about management dependencies, so they're vCenter, NSX controllers, we tend to stick them in a stretched management cluster, right? But Harbor is a cloud-native app. You can put it in a VM. It might be maybe worth thinking about. Git is GitLab runners. They're running Kubernetes. They're not running on a VM. So if part of solving this is going to your developers and saying, just redeploy on this side, well, yeah, but how about these? Maybe these aren't your concern. Make it someone else's problem. But they might assume it is your concern, right? Because, like I keep saying, infra solves it, right? This is basically just what I want to tell you. There's really nothing more than this. Be aware that this is an unsolved problem space in the community. Be aware that vendors are working on this to fill in some of these gaps. So is VMware. But we're not there yet. And you have to deal with this today because you start your cluster and immediately you're going to hit some of this. Takeaways, figure it out. And if you can't figure it out, that's what partners are for, right? And this one is probably the most important one. Don't assume anything. Don't assume that they will take care of their data concerns. Don't assume they will back up and restore their stuff. Do not assume they have an availability model. And they should not assume that the cluster is stretched or somehow magically will reappear on the other side, because it won't. They might assume that if they're used to cloud native in public cloud. So conversations. And this is the hardest one, seriously, because not all of us are used to talking with developers. And developers are certainly not used to or trust infra. But we're going to have to, because the only way to make this stuff successful is those two communities need to come together real fast to solve this kind of stuff. That was basically it. So, questions? How long do I have, actually? Off stage? OK. Shall I just stop it? Cool. Thank you very much.